Now, when we look at these systems of linear equations anyway, um, one of three things will happen. We'll either have lines that intersect in one point, like we had in the first two examples, A and B of number 1. We could have two lines that are coinciding, meaning they're the exact same line, or we could have two parallel lines that never intersect. And I've included this table here to represent these two, or these three different cases. And they are given special names. For example, any system that has at least one solution, whether it's one solution or infinitely many, they are consistent. If you have a system with no solutions, in which case the lines are parallel, they are said to be inconsistent. And then the two consistent types are broken down into independent and dependent. Independent meaning that we have just one solution where the lines intersect at just one point. Dependent solutions, or dependent systems, are two lines that are basically the exact same line. They basically lie on top of each other, so they have the exact same slope and same intercepts. Parallel lines have the exact same slope, but different intercepts. So if we look at these, and one thing you can look at to determine the slope is you can put these in slope-intercept form if you want. Now the top, if I were to solve for y, add the 2x and then divide everything by 4, and I'm not going to go through the work now, this is something you could do, but if I subtract, or add the 2x and then divide by 4, 2 over 4 becomes 1/2 x, and then 6 over 4 becomes 3/2. Okay. Doing the same thing here, getting the y by itself, we would divide everything by 8. So dividing everything by 8, we'd have 4 over 8x, which is 1/2. So this tells us that these two lines have the same slope. So we're either going to have the first case, coinciding lines, or parallel lines. Intersecting lines, lines that intersect in just one point, they have different slopes. So since these two have the same slope, then we will have one of those last two cases. Now, dividing the -12 by 8, -12 over 8, 4 goes into both of those, so we have -3/2. Now, if they would have the same y-intercept, they would be coinciding. If they have different y-intercepts, they are parallel lines, which makes it inconsistent. Well, 3/2 is different than -3/2, so this top line has a y-intercept of the point 0 3/2. Bottom one has a y-intercept of 0 -3/2. So therefore, these two are parallel lines. They are inconsistent, which means they have no solution. There is no values for x and y that make both of those true at the same time. Now in B, again, we can do the same thing. We can solve the top one for y. Pretty easy to do. We just add 3x to both sides. So the top line has a slope of 3, y-intercept of 0.04. And solving the bottom one for y, we would subtract the x and then multiply by -1/3 to get the y by itself. I'm sorry, multiply by -3 to get the y by itself. Good catch, those of you who caught that. So we will have positive 3x, and then the 1 times the -3 is -3. So once again, we have two lines that have the same slope of 3, but different y-intercepts. So once again, these two are inconsistent. They are parallel lines, and they have no solution. We will do the last two very quickly. Again, we can rewrite the top one in slope-intercept form as well as the bottom one. So in the top one, we would subtract the 2x and divide by 3, so we'd have negative 2/3 x plus 1/3, solving for y. And then the bottom one, all we do is subtract the 4. Subtract 4x, and then minus 3. Since these two have different slopes, they are two lines that would intersect in one place. So therefore, they are independent lines, an independent system. And finally, top one is already in slope-intercept form. To get the bottom one into slope-intercept form, we would subtract 6x, then divide by negative 3. So negative 6x divided by negative 3 is positive 2x. The 9 divided by negative 3 is minus 3. Now you'll notice that these two have the exact same slope and same y-intercept, which means they are the exact same line. So they have infinitely many solutions, which makes it a dependent system. So for quick review, if we go back to this table, intersecting lines, line systems that have one solution have a different slope. Once you see a different slope, you know they intersect in one place and you have one solution. Coinciding lines, lines that are a system of equations where the two equations define the exact same line, they have the same slope and the same y-intercept, or same x and y-intercepts. And finally, parallel lines where we have no solution. It's an inconsistent system. We have the same slope, but different y-intercept. So look at the slopes first. If they have the same slope, then you have to look at the intercepts to determine whether they are coinciding or parallel. If they have the different slope, you can stop there. You know it's an independent system where the lines intersect in one point. The next video, starting next week, will involve solving these systems algebraically.